Okay, so we're going to go through questions 3 and 4 of 6.5, moving shadows. Okay, so now in this case, we have, if we go back to the question, we have to calculate the location of Carlos's shadow at the times t given in the following table. So we have a table here. Okay, we have times. These are the times that we have to look into. So this is elapsed time since passing position A. Okay, so Carlos is on the Ferris wheel. So this is position A. Okay, so how much time has passed? And then what we have to calculate is horizontal position of the rider. Okay, so let's have a look. After, what happens? Let's erase this. Okay, so let's see what happens after 1 second. Okay, let's do the first one. So after 1 second, so Carlos starts here and then the Ferris wheel turns in that direction. So after 1 second, he's going to be about there. Okay, so we create this triangle here. So that means from this point, we drop an altitude here, which is going to be perpendicular to the horizontal. And we come up with this triangle with radius 25, which is the same as the hypotenuse. And we want to find this length x, this distance from 0. Remember, we have a number line superimposed here. From 0 to, so we need this value x over here. Okay, so now I can use my trigonometric ratios, and even better, I can think of trigonometric functions now. So theta, okay, but I need an angle theta. Okay, so theta is going to be, I know the angular speed is 18 degrees per second. If I multiply this times 1 second, this cancel out, so it's 18 degrees, okay? So I have my angle, very important. Okay, so I know that the cosine of 18 degrees is equal to x over 25. Okay, so I have everything I need to find x. So I'm going to multiply 25 on both sides. Okay, so this cancels. So x is going to be equal to 25 cosine of 18 degrees. Okay, so this is my calculation, and I can go ahead and put it here. So here the distance is going to be 25 cosine of 18 degrees. Okay, then you should go and get your calculator and put the answer here. Careful, it needs to be in degrees, not radians. And also, if you see, it should be a number just below 25 if you think about it. Okay, so if you get a number under 25 and round to 1 decimal place. Okay, so let's do another one. Let's do, maybe I'm gonna do let's do 4. Okay, and I'll let you do the other ones. Okay, so let's get rid of this and start again. Okay, so now what do I have? So I have this. So now from A, 4 seconds have passed. So now Carlos is going to be up here. Okay, so he's going to be closer to 0 on our number line. Okay, not quite there, but it's closer to 0. So again, I'm going to draw my triangle here. Okay, so this is going to be theta. So the radius is 25. So again, I know that the cosine of, oh, what is my angle? Here my angle is going to be 18 degrees per second times 4 seconds. Okay, so 18 times 4, this is 720 degrees. Sorry, 72 degrees. 72 degrees, okay, is equal to x over 25. So again, x is equal to 25 cosine and 18 times 4. You know, I recommend you keep everything like this. 25 cosine of 18 degrees times 4. Or you can put both. But we're going to be looking for patterns. So if you write it out like this. Yeah. Oh, sorry, it doesn't go there. And actually, let's erase this. So let's put both. 25 cosine of 18 degrees times 4, which is the same as 25. Let's get rid of this. Cosine of 72 degrees. Okay, and then we'll go ahead and put our answers here. Okay, so I've done those two. I'll do one more for you. What about 18? Okay, so let's do 18. So what is happening as we go on the Ferris wheel? So this is 0 seconds, position A, or 0. Then is 5 seconds over here, 10 seconds to get to the left hand side, 15 here, 16, 17, 18, so 18 degrees. Okay, so my angle really is all of this. Okay, and now what is theta going to be? Now in this case it's going to be 18 degrees per second times 18 seconds. Okay, so theta is going to be 18 degrees times 18, okay, which is 18 times 18 degrees. What is 18 times 18? 18 squared gives me 324. Okay. Okay, let's put it here, 324 degrees. Okay. All right, so using my same formula, now x is going to be 25, the radius stays the same, times the cosine of 324 degrees. Okay, and the way I'm gonna erase this, because I'm gonna put it in my table. So here I'm gonna have 25 cosine of 18 degrees times 18, which is the same as 25 cosine of 324 degrees. Okay, so go ahead, continue with the rest of the calculations. Okay, and then pause the video while you do that, and then come back to the video and we continue with the next part. Okay, so once you worked on your calculations and you come back to the video, you should have this. You should have these values. So have a look. Is this what you've got? Okay, so if you see what's happening in here, all of them, all the angles are 18 times the number of seconds times t. So okay, so in all these cases, theta is 18 times t, so that's something to notice. But there are other things that you could notice too. Do you see how values repeat? So let's have a look at, for example, you can have a look at these values for 2 seconds and 18 seconds. Do you see they both have the same distance from the center, exactly the same? Why is that? So let's have a look, and I'm gonna draw my wheel here. So what's happening at 2? So 2 seconds, I have an angle of 36 degrees here, and for 18 seconds it comes back here, and the angle is 18 times 18 degrees times 18, okay, which is 324 degrees, which is the same as negative 36 here. Okay, so here we're finding the cosine of 36 degrees and the cosine of negative 36 degrees. Okay, but if you remember by the journal you completed in your apex work, these two cosines give the same value. Okay, for both of them, the distance from the center is the same value. The cosine would be the same value. Okay, so that's something to look at. I hope you notice more patterns like this one. Like another one that I would like you to think about, let me erase this for now, is, let's have an, I wanted to have a look at this one, something, for example, for 8 seconds and 28 seconds. Okay, again, I have the same values. Why is that? Okay, and also a final one. Why is it that for 2 seconds I have positive 20.2? How is that related to 8 seconds? Okay, now in these two cases, they are the same, they have the same absolute value, but they are opposite. They are opposite. So why is that the case? So could you maybe draw another number line, another circle, and think for 2 seconds what's happening here. For 8 seconds, 5, it would be about here. Okay, so why do these have opposite cosines? So think about that, think about the angles, and keep on looking for patterns. Okay, so once you complete question 3, question 4 is about writing the equation, the formula. So it says write a general formula for finding the location of the shadow at any instant in time. So this is my formula, 25 cosine of 18t. Okay, don't add any factor here, plus c at the end. You don't need it in this case. If you think about the situation, we don't need any vertical shift in this case. It wouldn't make any difference. Okay, so that's questions 3 and 4. So just before you move back to, you continue with your ready, set, go, let's go back to the essential question and see if we have answered it. Okay, so essential question. How can I describe the horizontal motion of the rider on the Ferris wheel, both graphically and algebraically? Okay, so graphically we created this graph, and before you had to trust me in the fact that it has soft curves. It is not, it doesn't go like this, doesn't go like that, so you have to trust me. But now that we have the equation as well, that we also are able to express it algebraically, you can see, you can find for any time t, you can find the point on the graph. And if you go ahead and plot this on Desmos, you'll see that this is a graph that its behavior is like this. It's more like a soft curve, not doesn't have any corners. Okay, so please email me or